My name's Adam Fuoss. I'm the VP of Product for the EdgeConnect SD-WAN solution. I sit in the SASE and security product BU, so there's quite a bit of integration that we are working on to bring our products together. Just quickly, an overview of our SASE solutions. There's really three pieces to our portfolio. At the top, we have SSE, which is our cloud-based security solution, really heavily focused on ZTNA. Next piece down is EdgeConnect SD-WAN. This is to connect branches, data centers, the cloud. And then the third piece of all this is ClearPass and NAC. We actually have done quite a bit of integration throughout this whole portfolio, and that's what I'll be talking about today. We've integrated ClearPass into EdgeConnect, where we can get device, context, identity, all that sort of information. We've also integrated our SD-WAN and SSE solutions, and we're actually about to take that much further. So let me start off with the problem statement first. We have noticed with many customers that we are working on ZTNA type of solutions with that they have very much brownfield environments, and there are just applications that live everywhere. So branches, data centers, the cloud. And to connect to these applications in the ZTNA world, you actually have to use what's called a connector. And so this allows our cloud to broker users back into applications inside of the network. And this is all well and good when all the applications are in the data centers where I have infrastructure where I can run that connector. Traditionally, it will run as a virtual machine. But when the applications start living out in the branches, that's a whole different problem. I may not have virtual infrastructure there to run this connector. And that means that I end up having to connect to our cloud, connect to a data center, and then route across the wide area network to get to the application. So not necessarily the most efficient path. So what we have done, and what we're about to release here soon, is we have added the SSE connector into the EdgeConnect SD-WAN solutions. We're actually running this as a container. It is fully hooked into the data path of the EdgeConnect, and it runs as a service alongside our SD-WAN services, our firewall, our SWG automation, everything else that we have on this platform. And what this ultimately will look like for the end user, and then I'll show you actually how you deploy this, is that user now can just go connect to our cloud. That's where they get all the security brokering, all the inspection capabilities. And then our cloud is connected directly into the branch wherever that connector is enabled. So no longer are they having to hairpin through a data center or some gateway inside of the network. They actually can very simply connect right into the branch or the site where the workload lives. We've had a lot of customers coming to us saying, hey, we have third-party contractors and these other people coming into our networks to manage HVAC services. This problem is actually much more prevalent than we ever thought. And so people need to get into the site, down to the site, but they need to do it efficiently. So let me jump to our demo here. Put this out of the way. So what we're looking at here is the EdgeConnect Orchestrator. And in the Orchestrator here, we have our appliances on this side, and we have a tab here for HPE SSE. So this is where we've been adding integrations to build towards our unified SASE portfolio. Now, the one that's selected right now is our Secure Web Gateway integration. So we do have the ability here to actually go into a subscription, provide an API key to our SSE offering, and that actually connects our cloud orchestrator up to our SSE cloud. So they're now talking. And when I do that, what happens is I have the ability to form tunnels automatically to our cloud for Secure Web Gateway integration. So if I want to use a cloud-based SWG, I can very easily, at scale, deploy this across hundreds or thousands of sites, really with just dragging a box over. We automate the entire process of creating the tunnels. What we've added in is the SSE connector now. And so what we have done here is, and it's going to go ahead and sync, we can see we have some different sites that are selected up here, and we can see we've actually deployed this connector across a bunch of different locations. Now, I didn't have to install a virtual machine or do anything like that. I simply actually make sure I'm on the right version of the EdgeConnect operating system, and I go over to Connector Association here, and I can see what sites the connector is associated to. And if I wanted to, let's say, associate that connector to this site here, I would just say associate connector, or I could just do it to all of them. And when I hit save here, and I'm just going to skip this in the interest of time, it goes out, it calls the API for our SSE offering, it gets all the information it needs to configure that connector, it downloads the connector actually from our cloud into the container on the appliance, and then it actually goes through and fully completes the process of standing up the connector. Now, if I go look at the the access side here, we can see under settings and connectors, we have the connectors that are instantiated from the EdgeConnect orchestrator and from the fabric. And so what was a process before of actually deploying a virtual machine, making sure I had infrastructure at the site, if they're an SD-WAN customer, they very easily can connect the connector throughout the entire network really within minutes. So I tried to keep the demo straightforward today. I wanted to see if you have any questions.
The connector in this particular case, because access security is an SSE,
yes.
usually was endpoint clients,
yes.
right? But this is obviously an aggregation device, like gateway that's connecting to that. Is there a behavior or configuration change or policy differences within the SSE sort of framework?
No, there's not. So the connector itself, it would be the same exact way you would deploy it for anything else. It is the same exact software, actually.
Okay.
So for anybody using ZTNA to come inbound into the network to access applications, the policy is the exact same policy you would create today. What's kind of different, though, and what's really nice is we've created this nice walled garden on the EdgeConnect for the connector itself. Mm-hmm. And so packets exiting the connector traverse our next-gen firewall stack. So if I want to do IDS, IPS, or other sorts of inspection on the EdgeConnect for anything egressing back into my network or going back out, we actually have the ability to hook all that in right there. And so there is some additional capability that's actually added in as well.
And those policies are unified or separately, like EdgeConnect policies are still EdgeConnect policies? The SSE access security policies are separate still?
Today they are, yes.
Yeah. But the goal eventually is central unifies all of it, all the way through the Wi-Fi into the IoT device.
Absolutely, yeah. Eventually. I mean, we are driving hard as a company and product teams towards like universal zero trust.
Yep.
I mean, our view of the world is that you do the policy in one place. It's enforced at a gateway. It's enforced at an access point, at a switch port. It's enforced in the SSE cloud. This is something that we are definitely driving towards.
So it'd be like all the way to PVLAN, all the way to IoT device type, all the way through.
Yes.
Got it. Nice.
Does that include the HVM manager? So you're all the way to the data center, endpoint to data center, common policy?
I need to let whoever was going that one, but right now, like from the HPE Aruba Networking side, it's been primarily on our portfolio. Definitely that could expand out into other parts of the HPE offering though.
Hello, everyone. My name is Matthew George. I'm a technical marketing engineer focusing on NAC solutions like ClearPass and Central NAC. And today I wanted to give like a really quick overview about one of our newest offering in the NAC space, which is Central NAC. So our journey towards cloud-native NAC started way back in 2019 when we started doing the market research about what are the customer requirements. And one of the main takeaways was everybody wanted to have a very simple way for the users and devices to connect to the network without all the complexity that an on-prem NAC solution has. And with that in mind, we created the Cloud Auth Service in 2021 in Classic Central platform. And now in 2025, we have the new Central, we have Central NAC in the new Central platform. So let's see how Central NAC works. So all the APs, gateways, and switches that are managed by Aruba Central would establish a RADSEC connection to the Central platform. We don't use a Radius at all because Radius is inherently insecure and cannot be trusted over public cloud and untrusted networks. And once the request reaches Central NAC, we can do authentication and authorization against cloud-based identity sources like Google Workspace, Microsoft Entra, and Okta. In addition to validating the group membership and other attributes from the IDPs, we can also work with the Client Insights module in a new Central platform. Client Insights is the advanced profiling and visibility module within New Central, where we combine the device fingerprints. So traditional device profiling has always been based on static profiling, like using the device fingerprints. But now in Client Insights, we combine device fingerprints with the traffic flow information, and we use our AI ML models to derive very accurate and granular profile information about the devices that are connecting to the network. In addition to that, Client Insights also has these integrations built into third-party systems like MDM solutions like Intune, Jamf, Workspace ONE. We also have integrations built into endpoint security solutions like VMware Workspace ONE, or it could be Microsoft Defender or CrowdStrike. So leveraging all these integrations, we are able to fetch compliance attributes. We are able to fetch information like whether the device is managed or not. And we can use all of that as part of the NAC policies. In the new central platform, we also have the AirPass, a service called AirPass, which uses SIM-based authentication. This service is only available in the US today, and we support AT&T and T-Mobile. Central NAC also contains the Cloud Guest module, which offers several different types of guest workflows for visitor logins. And here I wanted to talk about some of the key use cases that we are trying to solve with Central NAC. And just like I mentioned before, like on-prem NAC solutions tend to be very complex, and is more suited for use cases that are very niche. Like if an organization has a lot of niche use cases, then maybe a complex on-prem solution might be a good fit. But here we are aiming for simplicity. So in terms of user authentication, we support .1x with ETLS with authorization against cloud-based identity sources. We do not support username and password authentication because passwords are considered inherently insecure. Vendors like Microsoft are on their way to deprecate username and password support in their operating systems as well. So now when we do certificate-based authentication, there needs to be a way to easily push a certificate onto the device and provision a network profile as well. And this can be done using an Aruba onboard app, or if you want to use different mechanisms, like if you want to use AD group policies or Active Directory, or if you want to use Active Directory certificate services as your PKI, or if you want to use Intune or Workspace ONE management to push certificates onto the device. All of that can be done today. So we added support for something we call the Bring Your Own Certificate, which means that we can work with external PKI and any kind of CAs out there. For user authentication, we also have MPSK-based workflows. So MPSK is multi-pre-shared key. And there are two flavors of MPSK. There's the user-based MPSK, where a user will log in using their cloud IDP credential, would generate a pre-shared key that's unique to that user, and then the user can connect all their personal devices. So this is really useful for like dorm room scenarios where I have a bunch of personal devices I want to connect. And so now MPSK lets me do that. Then there's the admin-based MPSK, where and this is more useful for devices that are not assigned to a specific user. So corporate-owned IoT devices, for example, right? So the admin would generate a pre-shared key, which then can be used with a device or with a group of devices. And for device authentication, we support MAC auth against a list of registered MAC address, or we can do allow all MAC auth as well. Sure.
So this is cloud native.
This is fully cloud native on the new central platform.
Okay. And so with it being cloud native, does it scale horizontally like indefinitely, or is there a set amount of endpoints that this can support from like because the physical boxes, you have like a hard number where if you're like over 50K endpoints, you need to put another box in place. So
yeah, so we haven't found like that upper limit yet. So based on our internal scale testing and the published numbers that we have is right now, the number that we tested against is like 100,000 users and 300,000 user groups in IDPs and 100,000 users. Yeah.
Okay, and so as far as like, okay, so 100K. So if a customer, with this being cloud native, it wouldn't be like site specific that they're authenticating their endpoints, right? So does that mean if the customer has more than 100,000 endpoints,
we can scale horizontally as well. This is just the tested numbers, but we can go beyond that as well.
Okay.
Yeah.
From a product portfolio perspective, so this is NAC services running in Central. Is this effectively replacing ClearPass?
No, it's not, because as I was mentioning before, like customers have very different use cases, and some of those use cases are more complex, whereas what we are looking for with Central NAC is to service those simple standard use cases where customers just want a simple way to connect devices to the network without the complexity. So if you're doing TechX, for example, right, there's no way to, there's no secure way to send TechX to the cloud. So then you would still need something on-prem.
Okay.
And sorry, my slide jumped ahead a bit. So in terms of guest authentication, it can be as simple as click to accept terms and conditions, or as complex as self-registration with sponsored access. We also have the AirPass service, the SIM-based authentication service, as I mentioned before, which is predominantly used for a frictionless way to get the guest users on the network.
So for captive portal deployment, does that make it easy with this, or the captive portal configuration is separate?
In terms of AirPass, or in terms
of, no, well, not that.
Central.
Generally, yes, central captive portal. Does that integrate with this? Or?
Yeah, it does. It makes captive portals easy. Like, for example, if you had a lot of sites spread across the country, then with an on-prem NAC solution, you might be thinking about building redundancy. So you might be placing 2 of those on-prem boxes at each site just so that you have local redundancy. But now with everything on the cloud, the redundancy is built into the cloud architecture. So that saves you a lot of work in terms of routing the traffic and in terms of deploying the on-prem boxes as well.
With this, can I do a policy that says as long as you have a valid Google account or GitHub account, you get access to the captive portal?
You can do that. So as part of our visitor solution, we support 4 different social identity providers. And that's Twitter, LinkedIn, Google, and Facebook. Yes.
No blue sky.
In due time. So let's do a quick demo. So this is New Central. And once we get to Central NAC, we get to see this dashboard where we break down information in terms of success versus rejects and reject reasons, the top sites where the requests are coming from. We can drill down into specific sites and see this. So we also have the client dashboard where we can see detailed information about the clients that are connecting to the network. So here, for example, if I were to search for a user called Adam, I can see that there are 2 different devices connected, one over the wired, the other one over the wireless. And now if I were to click on any one of these devices, here I can see that on the left-hand side, there's the user group. So this is a group membership of the user on the IDP side, which was used to derive the policies. And the outcome for this user was the role that was assigned, which is VIP employees. Now, one quick demo that I wanted to show is how well we've integrated the IDPs into our solution. So I'm going to remove Adam from the VIP employee group. And what that should do is it should trigger a notification to Central NAC that something has changed for this user, that the group membership has changed. And when we see that, Central NAC would check whether, does this mean that there is a change in outcome for the user? Does it result in a change in VLAN or a role for the user? If it does, then Central NAC would force a re-authentication and apply the new policies. And this takes a minute to happen. So while we are waiting on that, let's take a look at what device Adam is using. So on the bottom left-hand side under classification, this is where we show the information that we get from Client Insights. And we can see that Client Insights was able to accurately classify the device. On top of that, it was able to apply certain tags as well. And these tags are coming from our third-party integrations. So we have integrations built with CrowdStrike, Intune, Microsoft Defender, and we are able to pull in compliance and other attributes, all of which can be used as part of the NAC policies. And another thing I wanted to point out, if you look at the vendor, we can see that this request came from a Cisco switch. So we now have true third-party support where we can authenticate users from any kind of network infrastructure. And we can support all these complex workflows there as well. So now let's take a look at Adam, and we can see that the role now, the user group membership now changed to employee, the assigned role changed to employee, and the VLAN would have changed as well. So this is true zero trust in action. Like we made a change on the group in the IDP, we changed the group associated with that user, and that within a minute triggered a chain of events which led to the network access being changed as well. So this is one of the better ways that we have been able to integrate the NAC and the IDP together.
That happens on the reauth, right?
In a typical NAC solution, it would happen at the reauth. You would have to wait for the device to come again.
That's right.
But that's not the case here.
Okay, got it.
Here we get direct notification from the IDP that something has changed, and we force the reauth at that
Oh, you
point.
force the reauth.
Yeah,
point. Got it.
exactly. So it's more real time.
Yeah.
I ask, you mentioned everything was being done via RADSEC. Does ClearPass act as the CA server in that case? Or do you have to use like a Microsoft?
So you don't have to worry about the CA, the RADSEC client, or the server certificates at all, because all you have to do from a config perspective is when you set up a WLAN, you have to select a central NAC as the authentication server.
Okay.
And then the AP switch or gateway will, it knows what needs to be done. Will set up the RADSEC connection.
Okay.
It will use the TPM cert on the device as the client certificate.
Okay.
And the CA cert for the central NAC servers are built in as trusted CAs on the device side. So the RADSEC tunnel comes up automatically without you having to know anything in detail about the certificates.
So we're talking about wireless at this point, but is there support for wired as well?
Yeah, so this request came from a Cisco wired switch.
Oh, okay.
Yeah.
I missed that.
So we have both
Okay, so
wired
do
and wireless.
Is that true for third parties as well?
Yeah,
Cisco.
this came from a
There's a
Cisco.
Cisco switch.
Or, sorry, the
With
RADSEC CA question.
So the RADSEC CA, you don't need RADSEC for third parties. The way
Okay.
the third party support works is you need an AOS 10 gateway in between, and the third parties will send radius requests to the gateway. The gateway will then establish the RADSEC tunnel. So it acts as
Okay.
a man in the middle and the proxy.
So you're like Cisco switch would be radius to the gateway.
Yeah, keep
Okay.
things simple
Okay.
within the campus. Yeah.
Okay.
And here, so there was a question about like whether we work with wired and wireless. So both of these users, Adam, both of these devices for Adam, one was wired, one was wireless. And we can see that the role change happened for both of them. So it doesn't matter what infrastructure you're on, Cisco, Aruba, wired, wireless, all of these flows work seamlessly.
So does that also come into play when right now we're authenticating, we're authorizing, assigning a role. Where does enforcement of those authorization take place? Like if it's multi-vendor, is there the option to where, okay, great, I've given them this role, but what level of access do they have based on that role, and where do I enforce that access?
Yeah, that's a good question. So when it comes to multi-vendor, like if you take that Cisco wired switch, for example, role doesn't mean anything to the Cisco
Right.
switch. So we can do a VLAN enforcement as well. And that's what I was doing here. I was switching the VLAN for the user when that group membership was changing as well.
Can I map VSAs to that?
Right now, we only support VLAN and radius session timeout, but additional VSAs are something we are looking at as well. So in terms of enforcement, we can do VLAN enforcement or role enforcement today. Everything else is future.
But if it's VLAN enforcement, it would still be at the point where that traffic comes back to an Aruba switch?
Oh, no, it will be enforced at the Cisco switch itself. It doesn't have to come back to Aruba switch. So whatever infrastructure they have at that place, we can work with that. Yeah.
Okay, thank you.
Yeah, the gateway doesn't have to be in line to the traffic. The gateway just acts as the RADSEC proxy is all.
Got it. And this is nice. It's nice that you have a multi-vendor approach, because that certainly exists, and to where that you're able to assign roles to endpoints regardless of whether I was just curious about the next piece of the puzzle where, okay, what do we do with those roles? Where do we actually control the access that they're they're
Yeah.
receiving.
So you could like put a gateway in front and then take advantage of the roles. That's possible, but we haven't gotten down that far yet.
Okay.
Yeah.
Appreciate it.
And just the last thing I wanted to show is I talked about client insights, how it has a lot of valuable profiling information. So I just wanted to take like 30 seconds to show how much information, right? So if we look at the client classifications here, gonna go in deep. So here in my test site, I'm able to see detailed information broken down into like what vendor, what model, and what type of devices. So there are 3 IoT devices that are connected. Now, if I want to drill deeper into what those IoT devices have been doing, I can go into the Explore mode, click on the IoT device, and then it just sorts itself and shows me data that's relevant to the IoT device. And here I can see the external data upload. And if you want to create custom policies and rules based on this information, you can do that. So you can create custom tags based on the destination traffic, destination IP addresses, and so on. Any questions?
Yeah, one quick question. Just again, kind of going back towards looking down the road, because you're mirroring a lot of the functionality and capability within ClearPass that's there today. Is there any appetite or drive to actually migrate everything into Central and thus eliminating ClearPass?
So based on the conversations that we've had with customers, large and small, we don't anticipate that happening in the near term because ClearPass is still a big part of our NAC solution. And there's a lot of things that needs are on-prem. Like, for example, Central NAC only works with cloud-native IDPs. You cannot use any on-prem authentication.
Pointing back
sources.
on-prem, okay.
Yeah, so there are still customers using SQL servers for authorization lookups and such. So,
okay.
Yeah.
That kind of hurts my head, but okay.
All right. Yeah, I think I'm out of time, so thank you.
All right. So thank you for sticking with us. We're at our end. I just wanted to wrap up and say, I hope today you've seen over the last couple of hours just the way that we're really using data, right? That telemetry to really drive the experience, right? Whether it be the security experience, whether it be the endpoint experience, whatever we kind of turn that data towards, using AI fundamentally at the base of it, really is opening up kind of new things that we can look at and how we can drive networks in much more powerful and much more interactive ways, right? So that's really what we wanted to leave you with today. We've taken the approach of telemetry-based networking that's driving security, that's allowing us to employ AI at very deep, meaningful ways in order to grab an understanding of what's going on and help the engineers and the operators really get to the kind of crux of the problem and keep their networks humming along at the most optimal way. And then finally, really enabling that end user experience, even down to this idea of kind of NAC on potentially third-party devices, right? Truly integrating a zero trust posture across everything in the portfolio. So thanks very much for your attention today. I hope this has been really interesting.